Alright, what's up everyone? In this video we're going to be going over using all of our coordinate geometry knowledge thus far to help us prove some quadrilaterals. So we're going to be using slope formula and midpoint formula to help us prove some quadrilaterals. So recall from our last unit I told you guys this family tree was coming back. The classification checklist, right? These are all the different ways that you can prove figures to be whatever they are. So just be mindful, we don't have all of the knowledge yet to be able to use all of these methods. So what I want you guys to be aware of is that for this lesson, and you guys can actually cross this out on your checklist as well, for parallelogram, we can only use these two methods. So we can show that both pairs of opposite sides are parallel, and I want you guys annotating this into your checklist as well. So the knowledge that we can use if we want to show that sides are parallel is we need to use the slope formula. And remember that when we use the slope formula, so if slopes are the same, we know lines are parallel. Okay, now the other method that we're going to be using in this lesson is the fact that diagonals bisect each other. So for this method, you would be using the midpoint formula. Now the concept behind that is if the diagonals, if each diagonal has the same midpoint, then we know that they are bisecting each other. So make sure you have this written into your notes because you're going to probably need it as you're working through the questions. All right, now remember, if we need to prove something like a rectangle or rhombus, we're not allowed to just jump there. We got to go parallelogram first, but then after we have parallelogram, right, that's why this little checkbox is here. After parallelogram, we can prove a rectangle. The only one we're going to be able to use today is the fact that the angles are 90 degrees. So again, it's enough to show one right angle, right? So a note I want you guys to add to rectangles is that if we have a right angle, sides must be perpendicular, right? And what formula do you think that we can use to see if sides are perpendicular? We're going to use slope formula. And the concept behind that is if slopes are negative reciprocals, then sides are perpendicular. Okay, now for a rhombus, again, we have a parallelogram whose, and the only one we're going to be able to use here today is the fact that the diagonals are perpendicular, right? So again, this is kind of repeating itself from the rectangle one, but to test if sides are perpendicular, we're going to use slope formula. And again, I'm not going to write this all down because it's going to take a minute, but we already wrote it for rectangle. So if the slopes are negative reciprocals of each other, right? Well, actually, you know what? We will write it. If slopes of diagonals are negative reciprocals, then your diagonals are perpendicular, which is what we would want for a rhombus, right? All right, so make sure you guys have this down. Again, you're probably going to need it. And these are some tips and tricks that you guys need to follow in order to be successful with these coordinate proofs. Now, use the grid. It's going to tell you sometimes that the grid is optional. I promise you, it is not optional for us. You need to plot the points that they give you. Also, make sure your work is organized. Your work needs to be easy to follow, or else the people grading your questions on your tests or on your regions are not going to be willing to give you points if they have to search for your work. Make sure you have a set and written to justify your work. So if you're finding the slope of two sides and you notice that the slopes are the same, you should draw an arrow and like write that observation down. Say, hey, these two sides are parallel because their slopes are the same. Again, we referenced this already, but go down the family tree. You cannot jump straight to proving a rectangle or rhombus without justifying the parallelogram part first. And last but not least, you need one concluding statement to tie all of your work together. So these proofs are going to be very different from the ones that we've been working with. They're a lot more mathematical. So the vast majority of people enjoy these more. Depends on your preference though. So we're just going to get right into an example. So again, the first thing that I said on that tips and tricks thing is you need to use the grid. So they're giving us points and we need to plot those points. So they give us the coordinate of S is -2, 1. And when you're plotting these, please be careful. If you mess up plotting, you are going to have a really rough time. T is -8, -1. And then we have U is -7, -4. And then we have V is -1, -2. Great. So here is our quadrilateral, and we are trying to prove that it is a rectangle. So remember, for rectangle, we need to go parallelogram first. And the only method, there's two methods that we know right now. So first method we'll use together is using the slopes to prove that we have a parallelogram. Now, one of the first things that I said was you need to make sure that your work is organized. So the first sides that I'm going to deal with is I'm going to try to find the slope of TS, which is right here, and I'm going to try to find the slope of UV. Now, the reason why I'm doing those two sides first is because that's the first pair of opposite sides I want to deal with. So if those slopes are the same, then that's halfway there to proving the parallelogram, right? So again, see how organized I'm being? I have essentially a title for my work. So this is a title for where my slope work is going to go for TS. This is a title of where my slope work is going to go for UV. Now, when you're doing your slope, I recommend writing the points. So T is -8, -1. And then we have S is -2, 1. And the reason why we want to write them is so that we can do our whole x1, y1, x2, y2 business. Now our slope formula is y2 minus y1 over x2 minus x1. And now we just substitute. So our y1 is y2 is 1. Minus our y1, which is -1. Be very careful with your signs here. Our x2 is -2 minus our x1 value, which is -8. So I go slow. I literally go step by step. I don't skip anything. So now in the next step, I'm just going to simplify. So that 1 minus -1 is going to become 1 plus 1 over, and then that -2 minus -8 becomes -2 plus 8. And now I will write my final answer. So we have 1 plus 1 is 2 over 6, and then I'm simplifying again. We have 1/3. So I know the slope of TS equals 1/3. Now, we're going to find the slope of UV. I'm going to move this up a bit because we're going to need as much space as we can get here. So the slope of UV is going to be, let's write our points out, -7, -4, and then V is -1, -2. So x1, y1, x2, y2. So then we have slope is y2 minus y1 over x2 minus x1. Now we will substitute our y2 is -2 minus our y1, which is -4, over our x2, which is -1, minus our x1, which is -7. That numerator becomes -2 plus 4. That denominator becomes -1 plus 7. So here we get 2 over 6, which again simplifies to 1/3. So the slope of UV is also 1/3. So now, before I even do anything else, I am literally going to draw arrows to what I just discovered, and I'm going to say TS is parallel to UV since slopes are equal. And I'm labeling that on my diagram. Okay? Now, we're halfway there. We need to get the slopes of the other two sides as well. So the other two sides, right, we're going to need the slope of TU, and we're going to need the slope of SV. And again, I have titles for my work. I'll even go the further step of boxing these, making sure we can really see what's going on, because these questions can get pretty sloppy with the amount of work that goes into them. So T is -8, -1, and U is -7, -4, x1, y1, x2, y2. And again, we have our slope. So our slope, y2 minus y1 over x2 minus x1. And you might be asking, why do I write the slope formula every time? It's so that I don't mess up. Because because I mess up all the time and I've been doing this forever. So our y2 is -4 minus our y1, which is -1, over our x2, which is -7, minus our x1, which is -8. That numerator is going to become -4 plus 1. That denominator is becoming -7 plus 8. So here we get -3 over 1. So our slope of TU equals -3 over 1. Now for SV, we have S, the coordinates are -2, 1. And V, the coordinates are -1, -2. And again, we're doing our x1, y1, x2, y2 business. So now we have slope. Again, I'm writing my formula again because I don't want to mess up. And it also looks neat, very consistent. So our y2 is -2 minus our y1, which is just 1. Wow, this is the first one where we don't have that double negative going. Our x2 is -1. Oh, I lied. Here it is. Minus our x1, which is -2. So that numerator doesn't need to change, so I'm going to leave it. Oop, I almost messed that up. Our numerator doesn't need to change, but our denominator does. That's going to become -1 plus 2. So we get -3 over 1. So our slope of SV is again -3 over 1. So I'm going to draw arrows, and I'm going to say TU is parallel to SV since slopes, getting a little sloppy, are equal. And I'm going to label that on my diagram so that I can see what we've solved for already. Now, you can see this is neat work. It can get very sloppy, though, but this is probably as neat as it gets. You guys could probably be neater than me, maybe doing like color-coded stuff, but you don't got to do that. You know what I'm also going to do? I'm going to label the slopes that I found. So TS, I'm going to write m equals 1/3 right on top of it. UV, m equals 1/3. SV, m equals -3 over 1. And TU, m equals -3 over 1. So now I know that my figure is a parallelogram. So in the last thing, it says we need a concluding statement. These concluding statements are usually like a sentence or two long. So I'm going to start writing that right now. So right now we know that STUV is a parallelogram since both pairs of opsides are parallel. And I'm gonna, you want to make sure you don't want to lose silly points. So I'm going to go the extra step, make this as specific as possible, right? I'm literally going to write same slope. Or you can write slopes are the same, right? Now that we know we have a parallelogram, going back to our checklist, one way that we can prove rectangle, the only way that we can use for this lesson, is to show that one pair of consecutive sides are perpendicular, right? Because if one pair of consecutive sides, consecutive just means they come right after one another, but if a pair of consecutive sides is perpendicular, we know that there's a 90-degree angle there, right? Which is all we need. All we need is the parallelogram to have one right angle, and then we are good to go. So the good thing about this is we already have the work for this. We already have the slopes of the consecutive sides. So if you take a look, and I'm going to highlight, let's do a different color. The consecutive sides that I'm going to use are TU and UV. You can use any pair. It's going to be the same thing regardless. But what you should see is that the slopes are negative reciprocals of each other, right? -3 over 1 is the negative reciprocal of 1/3. So what that tells us, and we're going to write this in our statement as well, we know that TU is perpendicular to UV since their slopes are negative reciprocals of each other. I'm going to go the extra step too, and I'm going to say that angle U now, angle U is a right angle. Right? And I'll label that, and then I'm going to end by saying STUV is a parallelogram since, see, I messed up. STUV is a rectangle since it is a parallelogram with one right angle. Boom. So that's slope work. We didn't even have to do any extra work after that. We found the slope of all four sides, and then we were able to kind of use our logic to make that concluding statement. If you have all of this work and no concluding statement, you are going to lose points. You will lose points. So make sure that concluding statement is as specific as possible. There was another example that I was going to do, but I think this is enough for now. But you guys have to understand the concept of these proofs and what the Regents looks for. It's for organization, labeling your work, and making sure that if you have something in your concluding statement, that you have the algebra to back it up. So ask yourself, do I have the algebra to back up all statements? All right, we'll work more on these in class, doing different quadrilaterals, but this is basically the concept of our coordinate geometry proofs.